So we're going to go over making your own battery cables or power cables. This kind of applies just in general to power cables for your car, and really anytime you're crimping lugs. It's really all this is, right? We're buying some bulk cable and some lugs, and we're crimping it, right? Now, as it relates to cars, and this is going to kind of be specifically about the Mustang, just because I noticed that the original starter wire, which in my opinion is an ample size gauge anyways, the insulation is cracking on it and needs to be replaced. And a lot of times guys go out and they buy from the automotive store, they buy pre-crimped, pre-made cable. In my opinion, those are not the highest quality lugs. They're kind of thin material, nickel plated, whatever. We get good quality lugs, good quality cable. We cut it to length and we crimp it ourselves, put a little bit of heat shrink tubing on it to keep it clean, cut down on the exposed metal conductive areas, right? So I'm just going to show you guys a real easy way to do that. This is real high quality American made wire. I'm always kind of going after American made stuff. And let me talk about that for a second. So it's not that I don't like stuff that's made in other places. I like stuff that's made in places where there is quality control and they care about their product. We tend to do that here in the States. Some places like China, although there are some manufacturing plants in China that make stuff, they actually make decent stuff, but a lot of stuff comes out of there without QA, QC, quality control. So, that's generally why I like American made stuff, because we have rules here and, it needs to be made to standard. So anyways, this is high quality stuff. I get this on Amazon because I don't need 100 feet of it. I can buy it in shorter lengths. I pay a little bit more because of that, but I also don't want to have to store spools of cable around. This is good quality, fine stranded, welding cable is really what it is. It's 105 degree C rated cable. You actually see that through there. 105 C. I've talked about this before in other videos. The current carrying capacity of wire is not just about the size of the wire. That is important, but that's not all there is to it. You can push more current through a smaller wire. It's just going to get hotter. The certification of the wire, of what temperature it can handle, is what's important. That allows you to run more current through it because the wire can run at a warmer temperature and not fail. That is mainly what it is. A 60C or an 80C wire can handle less current than a higher temperature wire. So anyways, this is 2 gauge. This is way more than it needs, quite frankly. And by the way, you don't rate on a starter motor, the thing's on for 5 seconds. Or it should be, unless you're trying to get something started and you're cranking it for 30 seconds and then the wire will get hot. But you don't need, just because you're pushing 600 amps or 500 amps through it and the cable's rated for 300 amps doesn't mean that you can't do that. You can push a large amount of current through this for a shorter amount of time. That's okay. This rating and the rating of the ampacity and temperature rating is for continuous use. Remember, we're not in continuous use when we're talking about a starter motor. So anyways, so I'm going to show you that. By the way, if you buy a pre-made cable from the auto parts store, it's going to be cheaper than this. This is not a cost thing. This is a quality thing. So, I think one of those cables you'd probably be had for 10, 15 bucks. This right here, this wire was, probably 20 bucks. Terminals here were probably another 10 bucks. So, you're talking getting into 30 bucks even if you don't have the crimping tool. And I'm going to show you the crimping tool in a minute. That's a one-time buy kind of a thing, and they're not that expensive, but you're going to get the length of the cable that you want, and you're going to get a quality, good connection, which is, very important. So let me grab the crimper, and I'm going to show you what we're going to do. All right, so here's the wire that we're going to be replacing right here. This looks like this is probably 4 gauge to me right now. So it looks original as far as I can tell. It looks like a factory connection there. The insulation is cracking, which is not a big deal because this is only on whenever you're cranking it. But, I don't like it. I want it to be quality, and I want reliability, and I don't want exposed wire. And that comes up to the solenoid, obviously, right here. I went ahead and got lugs for... I couldn't remember, and I was too lazy to come out and check. The starter, I couldn't remember if it was quarter or 5/16. It looks like it's 5/16, though. And this, I did remember that this was 5/16. So I'm talking about the hole size in the lug. So I went ahead and I bought lugs for number 2 wire with a 5/16 hole, because that's lugs you got to buy for the size of wire and the hole size that's in the lug. So I just bought some. I don't mind having a few extras lying around. I'm going to have extra cable laying around too in case I need to make any cables. So we're going to go ahead and get this off of here, and then that way I already know exactly what length I need just by pulling this off. So we're going to be replacing that, and then let me show you the crimper too. And this is the crimper. This is the poor man's crimper. This is great if you're not doing this every day for a living. These work really well. They're a hammer style crimper. So you put them on an anvil, or I put mine on the ground, some solid surface. Put your lug in there with the wire in it, and you simply whack it, and that'll give you a good solid crimp. They make crimpers that have handles, like a cable cutter style, except it's got a crimp tool in the end. Those do work better. They give you a little bit better crimp, but at the same time, those things are like hundreds of dollars, and they're for the guy that's doing it for a living. This works fine for the guy that's doing it in his garage a couple times a year. These are real good for that. So I think these are about $20, $15 or so. This is a Lincoln Electric one, because in the welding world, you have to make new leads kind of often in the welding world. And so I think that's, why that's Lincoln Electric. Anyways, I bought it because it was whatever was on Amazon. So I'm going to pull the old one off, like I said. And then that way we've got a measurement. We'll just make a new cable for it. So I got the old one out, very easy. So I'm glad I checked this out too, because I had noticed like these cracks right here. And, like I said, it isn't energized all the time, but take a look at this. It is totally failed, and this was up against the body. It was right up against the fender, the skirt, so eventually that would cause a dead short as soon as you crank it. So look at that original Ford Motor Company. It was time, I would look at how original that is. It's even got a date code on it, C6DF, and that just concurs with everything on this car, how original it is. But it was time. It's got to be replaced, and we're going to do it with higher quality stuff. Well, you know what? 60 years or however old this car is. What's it, 55 years old now? You can't ask for more than that, right? But, not everything lasts forever. So anyways, we'll go ahead and get this unwrapped. We're going to straighten this out. I'm probably going to add an inch to it. It seems like this is just a hair short, but, so I don't know. I might add an inch to it, but we'll get this unpacked and cut it to length, and we'll show the crimping of it. Okay. So let's get to making some cable here. So I went ahead and I cut this to length, and I just kind of eyeballed it another inch or two. And, let's go ahead and look at that for a second, because, you don't see it that often anymore. Anyways, first thing we're going to do is we're going to strip back the insulation, and we're going to put the lug on there and crimp it. In this particular case, because the lugs are relatively small, they're not much larger than here, I'm not going to be putting the shrink tube on here first. I'm going to put the shrink tube on here afterwards, just because it's a little bit easier to deal with it that way. But you could put it on first if you wanted to. It doesn't matter. You have to think about that if you got a real big lug or something and it's not going to fit. You just think ahead, because then you might be redoing a connection. That's, by the way, in case I needed to do more, if I made a mistake, that's why I bought more than just 2 lugs. It's always buy a little extra hardware. It's cheap insurance. Otherwise, you might be waiting for it. What I'm going to do with these, I usually just kind of eyeball these. And I was an electrician for several years before getting into engineering, and a lot of practical stuff that you learn over time doing that. I think that my opinion is that everybody that's an engineer, they should have to go work in the field for 5 years maintaining stuff first. That's my opinion. So I'm just kind of eyeball it here, and if I need to trim a little bit more off, I can. But you just kind of want to, well, it would help if it was in frame now, wouldn't it? You just kind of want to get a decent idea where that needs to be, and that looks pretty good to me. When you're stripping wire this big, there are other ways of doing it, but here in my garage, I just take a utility knife and just roll it. Now, you don't want to cut it too hard, because you can cut strands off, and we don't want to do that. As you see, I lost a couple, but it's fine stranded. It's very easy to lose a few. You don't want to do it to where you lose a bunch of them. So that's it. And then you slide it off. By the way, a trick with these, I did it and I didn't even think about it. A good way to get the insulation off is you bend it. And that's the other thing too. You can actually score it. If I'm careful enough, I'll try and do it on the next one and show you. If you're careful enough, you want to score it just to the point where it doesn't go all the way through, and then you can snap it. You can kind of bend it, and it'll rip what's left of the insulation off. Then you won't have to worry about any strands being broken. I'll show you that on the other end. All right, so then you take your lug and you put it on here, and that looks to me like that was just the right amount. Okay, now the way that I like to use this one, this is just a matter of preference. On these it doesn't really matter, but I know how I want it to look. I'm going to flip it upside down because I want the crimp side to be on the bottom. I don't know, that it doesn't matter. I just think it looks better. So you go ahead and you put it in here. This thing's spring loaded to kind of help hold the lug, and you kind of center it in here. And that looks pretty good to me. Make sure your wire's in there. And, well, it would just behoove me to have a hammer right now, so I better go get that. All right, so this is a little bit better. So for this, you get your MFH for this, your medium finest hammer. And just make sure that it's in there. And now, I normally would do this on the floor, but since we're here, I'm trying to film it on the bench. I put a big thick steel, this is like a 1-inch thick steel plate that I've got to make it so I can do this on the bench. But normally just doing it on the concrete is just so much easier. If you got an anvil or a big vise that's got an anvil on it, that's a good way to do these. So quite simply, I've got it seated in here, making sure that the wire's all the way in. That's it. It's crimped. So that's all it takes to do these, and that will not come apart. So let's go ahead and do the other side. We'll just do this right on the fly here. Like I said, this is not difficult. It's basic tools and just a little bit of know-how, and you could really save yourself a lot of time, and you can make your wiring cleaner because you get the exact length that you want and everything, rather than, because otherwise they sell these in 3 feet, 2 feet, 12 inches, 3 feet. Oh, I already said 3 feet. 6 feet. It goes from like 3 feet to 6 feet, or 3 feet to 4 feet. There isn't anything in between, is what I'm saying. So let's go ahead and we'll do the same thing here. And that's about where I want it right there. Let me see if I can score this one a little bit lighter. All right. Let's see. Just barely. See, now you're gonna have to look really. Well, jeez, I gotta stay in frame here. See how there's just a little bit of insulation left right there? It's gonna pop when I pull it. See, it just popped. That's the best way to do these, because then you're not cutting any strands. You want to make sure you don't cut any strands. You want to make sure you don't cut any strands. Did I say it enough times? All right. Insert it. Set it. And make sure that you get the lug centered in there. You really want it to be, you want even pressure. You want it crimped evenly is what I'm saying. All right. It's ready to go. Don't miss. That's it. Nice, good, solid crimp. It's not going anywhere. Okay. So now this will easily go in there. Let's get some heat shrink tube. All right, now I've talked about this heat shrink tube before. This is 3-to-1, so it's a higher ratio shrink tube. It also has the glue inside of it. You see it's a little shiny in there. I like this stuff because it glues on there. It seals out moisture, and it's high ratio, so it, well, quite simply, if it fits over stuff easier because it's larger and it shrinks down tighter. It allows more variability in what you're doing. Normally I'd get a heat gun out, but this is just 2 of them. It's real easy for me to do it with a torch. It's faster and I'm lazy. So as you can see, it fits right over. Okay. And remember, it shrinks, so you want to make sure you cut it a little bit long. So we're going to have it just like that. We'll get our professional looking cable this way. So if you are using a torch, you got to be really careful because you burn it real fast, It'd be like trying to bake a cake at 500 degrees in your oven. It's just burn the outside and it won't shrink or melt the glue on the inside. So the trick is with using these, you just keep it moving and then that won't happen. Like I said, heat gun is the right way to do it. Otherwise, somebody will tell me that I'm not doing it right. And I realize that. There it goes. All right. That's starting to look really good. All right, so you guys get the idea. So let me go ahead and do the other one. I won't bore you with that. And if you're doing it right, which it needs just a little bit more, I think, right here. Turned it up just a smidge. If you're doing it right, you should see the glue kind of start to squirt out on the ends. There it is. So you can see, well, you might be able to see that there's a little bit of glue coming out of it. So that means it got melted and it's sealed up now. It's just good because moisture otherwise can get inside and settle down in there and eventually corrode it. So we just want to seal that out, and it looks cleaner that way, and it's less exposed contact material. All right, let me get the other one done, and then we'll get it reinstalled. A note about reinstalling it, I did notice when I pulled this apart, and I bet you that solenoid's probably original. It looks to me like it's never been changed. Look at the corrosion and stuff in here. No wonder the thing cranks slow when it's cold. I knew that this was probably an issue. It's not so bad on the backside where the solenoid was. So, but I'm going to clean it and I'm going to spray some anti-corrosion stuff on there. I've got a little spray I'll show you. So we'll just take a wire brush to it and clean it up, make it nice and neat. And that'll get us a real good connection. All right, so we're just about ready to install the new cable. I went ahead and I cleaned these connections up with a wire brush. I cleaned the one on the starter up a little bit too. That makes a big difference. This is only 12 volts, and actually when you're cranking, it dips below that. Dirty connections and low voltage just don't go together. You can have a dirty connection at 110 volts, and it'll never even feel it. It'll get hot because, you're pushing current through it, but which isn't good and eventually can lead to a failure, but it'll push through it. When you're at a lower voltage like this, you think about voltage like pressure. I always try and explain it that way. A lot of folks aren't electrical, and so I aim to kind of try and help make that stuff easy. And when you have low pressure, having a good, nice, large size pipe is a good thing, right? Kind of like drainage. If you think about the drainage, storm drains at your house, or your yard drains. It's a big 4-inch pipe because there's no pressure behind it. The same thing kind of happens here. If you have a bad connection, it won't push through it very easily. You got to have a good, solid connection that's got plenty of capacity. That's why, at 12 volts, that's why this cable, this is large enough to supply all the power for your house on one leg. So if you got a 240 volt system, you got 2 of these, right? Which is most North American stuff is 240, which, 120 and 120. Believe it or not, a 2 gauge, that's going to give you, 80, 90 amps, no problem. If it's standard building wire, this is higher temperature, so it's rated higher. You can power your whole house off of that, right? That's because the voltage is so much higher. We're talking real low voltage here in your car. It's at the bottom end of the spectrum as far as things go. So it's, large cables are important when you're talking about low voltage, because we're still using a lot of watts, right? That starter motor is probably like 3,000 watts, 3,500 watts, but you're doing it at 12 volts, which means your current's got to be a lot higher to get the same wattage, right? Because quite simply, current and voltage is wattage, right? That's all it is power. Very simple. So I've rambled on long enough. We'll go ahead and get this reinstalled. I've got some of this Permatex protector sealer stuff. This works really well. It does prevent corrosion. It's really for your batteries, but we'll get it on the connections here, and it will prevent them from getting any corrosion in there. So let's get this reinstalled. All right, it's getting a little dark out here, but we got it installed. So this is the new route that it kind of takes here. I might throw a P-clip on this thing, but I went ahead and I added some fluted tubing to it, where it touches the frame down there now. It was I didn't like how it was kind of strung across before. It needs to have some movement because it's attached to the engine. It needs to be able to move. But I also don't know that I want all the weight hanging off of the solenoid either. So I might, if the light will be in the right place here, but I might put it up or put an attachment point on here or something. But I want to also keep it away from the exhaust as much as possible. Just the heat's not so good for it. But anyways, this will work really well. So anyways, I just wanted to show you guys that real quick, and get some, it's kind of some basic information for folks. If you didn't know it, you can make your own connections. And these are nice, thick, look at how thick the lugs are on here. That's solid brass. So, that's better than anything you can buy in the store. It costs a little bit more, but, if you want quality, it's the way to go. So anyways, hopefully this is helpful as usual, and we'll go ahead and wrap it up. And let me just add real quick, holy crap, did it change how fast it cranks when it's cold. I mean, it just turns over so much faster. I didn't realize how bad the connections were on that thing. But, that's always something to keep an eye on. And I know better, too, especially battery connections. Now, this cable is new, battery's new, cable's new, so that was all good. But, I hadn't checked this one as thoroughly as I did after I could see it when I pulled it out. So, yeah, a huge difference there. So definitely worth doing it. She sure cranks over well. All right, we'll wrap it up.